So today I just want to go through some Excel functions regarding matrix multiplication and use that to explain how we come up with the standard deviations for an investment portfolio. And it's probably worth going through this given that a lot of the explanations that I've seen for this online take, or at least appear to take, some things as given. I don't think the explanations are very in-depth, so I wanted to go through that stuff today. Now, I like to start from scratch, though I can just show you guys more about what's going on here. So first things first, right? First, we're going to need to understand the way that transpose works, and basically if I take my rows, transpose them, I'll get columns and vice versa. So, if you're not familiar with Excel at all, well, you probably should probably check out a more easy tutorial, but these are rows and these are columns. So that's number one. We can move rows to columns and columns to rows by using the transpose function. So transpose rows equals columns and vice versa. Now we need to know what the standard deviation for our portfolio is and what function we use for that, because it's not like we just take the weighted average. With something like the returns, we would take the weighted averages. With the standard deviations, we don't, because there's also an interaction effect. So what we would do is we take square root of the sum I of sum j, and basically it's just double sum for our assets I and all other assets j in the portfolio. And from there, we want the weight of I times the weight of j times the covariance of ij. And then close the brackets there. All right, so we take the square root of the double sum weighted weights of asset I times weights assets j and the covariance between the two. So in other words, basically the way this works is we iterate through all of our assets I, and then per asset I, we iterate through all other assets j and return the product of the weights and the covariance. Okay, so that's the formula now, or at least the math behind it. Now in Excel, what this looks like is equals square root, and then we use matrix multiplication, and then as our parameters for the matrix multiplication, we take the product of the matrix multiplication of our weights as rows, and we'll see why in a minute, times our covariance matrix. And then the other parameter that we take is the weights as columns. So that's what I think it's enough brackets, it doesn't really matter. Okay, so let's show how to get those though. So first, we have a covariance matrix, and actually let's just start off with our assets because it'll be easier to explain in this way. So let's start with assets, weights, set, we'll put this in a matrix form. So we're going to say that we have 5 assets, let's say. So I use sequence to get all of my number sequences, even if they're relatively short. You could also, I'll show you another way to kind of do this in relatively quick fashion. But we have one row. We take 5 columns because we have 5 assets. Step 1, start at 1, step up 1. So we get a sequence of to 5. And then, maybe another relatively easy way to do this is by just adding 1 to the previous, and we can iterate down to 5. But I prefer to use sequence, and as you'll see here in a second, because I'm taking 5 rows, 1 column, and stepping up 1, we're going to get spills, so I got to delete those. Anyways, so I prefer to use that function because I don't like typing everything out, which makes more sense when you're dealing with a larger data set. A small data set like this, you don't really need it for. So we're not going to use 5 sets of assets because I just want to illustrate a point. So we're going to use 3 asset sets instead of 5. And for no fill. Okay, and then we're also going to take a covariance matrix. Now, one thing that you should note, and it's not super important, I guess, but if we have a covariance matrix for assets, then we are going to end up with a square matrix. We don't need a square matrix to do matrix multiplication, but it's just because of the symmetrical nature of the covariance matrix and the fact that we take assets on assets, so the count for the rows and columns is the same. Now here we're going to use the transpose function just in if you didn't understand what transposing the rows and columns looks like earlier, that's what it looks like, right? We took this row here and transposed it into a column, and we could do the same thing going with the column as well, to rows. Oops. One useful thing too is that if you haven't already, you should go and learn the Excel shortcuts. I think they're pretty useful for speed. So what we're going to do is we'll just generate these matrices. Now, normally, like if I was, so for example, for the last Monte Carlo I ran in, well, actually the last one I used VBA, but the one before that I used rand array. I don't want to use random array here because it's probably going to confuse the lesson, but you can also just quickly fill an array using rand array. Kind of like you can do in Python with a range, but anyways. So we need one row with 5. So we're just going to start like this. We will need to normalize these, so we're going to add a sum to the end. And hopefully it doesn't, yeah, okay. So I've noticed sometimes when I just leave it as the hash, it messes up when we copy down. So I don't want to do that. I'm just going to add 3 to each of these, and we're going to, let's just copy this down, but we want to take brain fart. Okay, and then we'll just copy this one down. Oops, 1. Okay, cool, so there's that. Now, to normalize these, we're just going to take these, and we're going to divide this by 15 in this case, because the sum is 15, and we want all of these to add up to 1. Now, for this one, we'll put these in brackets and divide by 16, and after we do this, we should also find that the next one's also divided by 16. So if we copy this down, and yep, you see that, that's right. So actually we'll just go above, copy this down, and then copy this like so. Okay, so those are asset weights. Now for the covariance matrix, we're just going to do a similar thing. Actually, I'll just copy over from here, and then we're going to remove the normalization. Normalization is just a word for like we make everything add up to 1, so it's at least in this case. There's other cases of normalization, like your Z scores, for example, which is a little bit different, but that's what we mean here when we say that, is we just give them standard. So yeah, anyways, so we have our asset weights and our covariance matrix for, basically this is the covariance of the returns from the assets. So I should even, whatever, it's fine. Okay, so how does, to understand the way that like the MMULT function works, we want to understand how matrix multiplication works. So if you recall from linalg, we basically are going to take each of these elements in the rows. So we're going to iterate through the rows for the first matrix. So we're going to, this is matrix 1, and this is matrix 2. We're going to iterate through each item or each column in each row, and for each column per row, we're going to go through the columns in the covariance matrix here, or matrix 2, in that order, and sum the products. So we take 0.067, for example, multiplied by 1, then plus 0.133 times 4, plus 0.2 times 7, plus 0.27 times 10, plus 0.33 times 13. Okay, so we take the sum of the product. Now, as you can probably imagine, so let's just kind of start by going through that. And we are going to standardize this as well in a second. So I'll show you at least 3 ways to do this because we want to understand these things from the ground up. You don't have to, but if you do, then you'll have better time moving across different tools and be able to actually make modifications, right? So that's what it looks like when we, do the first matrix. Now, one thing that we, maybe that's also worth mentioning is being able to understand the notations here. So when describing a matrix, we would describe first the number of rows to describe the dimensions, then columns. So this is, for example, a 3x5 matrix. And this is a 5, having 5 rows, and then 5 columns, 5x5 matrix. So one of the things that we also know is that the product is going to be the result of multiplying these two matrices is going to return us a 3x5 matrix, because the way that we iterate through each of the columns in the rows for the first matrix. And one thing that I do want to point out, though, is that if we had, let's say we're doing this backwards, right? We'd iterate through these columns in the covariance matrix and then multiply by the rows in the asset weights matrix. And what that would result in is we basically have up to the third in terms of rows to multiply by in the assets weights matrix. But then when we go to the fourth and we go to look for the fourth row, we find there is none. So what would happen is we would get a value error in return. So we can't do that. We'd have to have the same number of rows in the matrix that we're multiplying by as we do columns in the first matrix. So keep that in mind for later, and I'll give you a quick reminder one. So now if we wanted to, be able to just like copy and paste this down, what we need to do is we need to hold each of these in the respective columns as we copy down, and each of these items in the respective rows as we copy across. So for these ones, so we're going to use the F4 key. F4 is basically what locks these, so we need to lock these to the columns, and we put these in order so they all easy to follow. Right, so we lock these to the columns, and then for these we lock these to the rows. Right, so just $13, for example, $14, blah blah blah. Okay, so we get that. Now if we go to copy this to a 3x5, and I will expand that just to show you, like, the rest should return 0 on the border. Because there is no matrix, right? So just to the point of earlier, as this is a 3x5. Okay, now the other way to another way to understand this is with and we will get to the matrix multiplication. I'm just explaining that there's multiple ways to kind of go through things. The next one is through SUMPRODUCT. This one's also relatively easy to understand. So if we go across, and this better work later. I don't know. I'm just going to put it as a manual. There are some problems with doing it in that manner, so we're just going to. I've noticed that, like, the hashes don't seem to copy down well, so we're just going to put that in manually. Now we need to lock this to the columns. Now when we go and select our array over here, so basically we're doing SUMPRODUCT. This is going to do that iteration we did above for us for the row here and the column here. And what we're going to have to do, though, is now we can transpose the row as well, but we're just going to transpose the column here, because for SUMPRODUCT to work, we need them to be along the same plane. And now we need to lock this to the rows. So, okay, and then what we should notice is we get the exact same matrix, which we do, right? And you can see that the numbers line up. Okay. So that's even faster. Now, obviously, like, the main function we have is matrix multiplication, and this is just to understand how this all works, is we get the matrix. So that's obviously the easiest way to do that, but that's just explaining how this all works along the way. Now, as I had mentioned earlier, too, just to make a point quickly now, is if we do it in the wrong order, and we have the number of rows exceeding, the number of columns exceeding the number of rows from the first to the second matrix, respectively, then we're going to get a value error because there's not enough rows to multiply by. Okay, now the other thing I want to do is, what we did right here is we have now dealt with this part here. We multiply the weights by the covariance matrix in that order. Now, let's just kind of write that down. Let's say this is weight I times, the covariance is ij. Okay. So that's what we have so far. That's step 1, if you will, or the first parameter that we take in the matrix multiplication function. But we do need the second parameter, which is two things. We need the weights by the columns, right? So we can separate these. Usually you don't. So I'll just quickly show you what transposing the matrix looks like. And we'll just concatenate the functions, basically. So if we take the weights here and we transpose them, we'll get a 5x3 matrix like so. So there's that. And this is going to allow us to multiply in the opposite order, where we take the result here in this formula, if you see, and multiply by this, because if we do it in this order, again, we're going to have 5 columns, and we want to multiply by 5 rows. So we need to transpose that. So we go and write that. The result of this is basically MMULT, like we have in the formula. We take MMULT here, or like the result of the multiplication up there, and we need to transpose this array here, like so. And we get that. Now, I mean, you can check if you want. You don't have to. But here's MMULT for, let's say, this array and this array. Okay. Oh, they're the same. Okay. Which we already knew. Okay, so this is, let's call this parameter 2 in the matrix multiplication function. Oh, jeez. Okay, and this is basically our weight I times parameter 1, or weight j times parameter 1, which is also weight I times covariance ij. It doesn't matter which order you place this in. Multiplication is, I think it's distributive is what the property is called, but it doesn't matter. Okay. Where do I put this? Okay. So there's the two parameters that we're looking for in the matrix multiplication function. Well, this is technically the total result of the matrix multiplication. This is more like the parameter 2 is like just weight j, basically, or this. Transposed. So then we just take the square root of this and, square root, take this, and we get our standard deviation. So now, how does this all work when you put it into one function? So let's just kind of remove all this to go through this and put it as one function. Okay, so we do square root, because we want the square root, and we take matrix multiplication as the parameter, and then within the parameter 4, and you'll see that we have one array. We need to specify 2 arrays. The first array is going to be the result of the matrix multiplication of the weighted matrix, where we have the asset weights as rows, and then the second array is going to be our covariance matrix. Okay. Now, after that, we need to take the transpose value, or our asset weights, as columns. And again, these are the assets. These are the weight sets, if you will. So columns. Okay, so that's the second parameter, and then we close that, and we close that, and we get this. So that is effectively how we get those standard deviations of the portfolio. Now I think I have the So you'll see here, this is another project that I had created using a covariance matrix, and if we flip over to the Monte Carlo, we have the standard deviation right here, and that's the formula we use. So, and basically, I'm sure you guys know what a Monte Carlo is. Actually, you might not. Okay, so the Monte Carlo is basically like a random simulation of normal distributions. Like so. So here we just generate a random array, and then sorry, the Monte Carlo doesn't have to use a normal distribution, but then we use that basically to generate the random asset weights across 10,000 iterations. You can do more. You probably should do more, to be honest. It's just that it's hard to handle, I think, a very large amount of data in Excel. Doing this in Python, for example, I found that you probably want to do close to like 100,000 iterations to get something that's more consistent. A data set this size, it might even be more, because I think there's like 15 ETFs here, somewhere around there, that we scanned. So, but that's the formula we use. This is the covariance matrix, and these are the asset weights we generated. So that's it in action. Okay. But that's what we get. Okay. Cool. So hopefully this was helpful. This is just like kind of the full explanation for using the matrix multiplication functions. There are other matrix functions that I will probably go over, because they're also useful for things like, you can use determinants to solve for systems of equations. So that can be useful for like demand analysis. But, you don't really need to know this, but I did find that online, I don't think people have explained this very well and why this is in order. So understanding why things work like this help you not rely on remembering the formulas, because you can construct it from the ground up if you have to. Anyways, hope this was useful. All right.